So in this next part of the video is going to be talking about how to calculate concentration and the molarity of a solution. So in this part of the independent study, we're going to review concentration. And concentration is the amount of chemical in a solution, or the amount of solute in a solvent. And it is always expressed as molarity. Now, molarity and concentration are synonymous. So these two words are basically interchangeable. Now, the solute, just note, solute is what is being dissolved, or what is being dissolved, typically the solid, and the solvent is what is doing the dissolving. It's what the solute is dissolved in. There are two pieces of information that you really need to know about concentration. And concentration, by definition, is the ratio of solute to solvent in a solution. And in order to calculate a concentration of a solution, or the molarity of a solution, you need to know the amount of solute being dissolved. In this case, we have a mass, but when we talk about amount right here, when we talk about amount, it is always going to be in the form of moles. So you may have to do some type of conversion. And the other piece of information that you need to know is the final volume of the solution that you are preparing. So in this case, it's 100 milliliters. In chemistry, concentration is always given in terms of moles per solute per liter of solution. So if you notice, I've underlined moles and liters because those are our units that we will use to determine the concentration. And concentration is always equal to the moles over volume, or number of moles per liter. It is also important to know that this is going to provide you a derived unit of moles per liter. Now, we can abbreviate moles per liter to capital M. So anytime you have a capital M, you can always change that to moles per liter. So let's say I have a concentration of 6.00 molarity. I can just go ahead and write 6.00 moles per liter. Same thing. Just note that capital M is an abbreviation of the derived unit of moles per liter. So let's go ahead and do a couple of problems. Now in the next 4 problems, I'm going to show you the different problems you'll encounter when you're trying to calculate concentration or find out information from from concentration. So if you're given 2 moles of sucrose and 0.5, and you have a total of 0.5 liters that you're forming, what is my new concentration? So here is my moles and number of moles, and here is my volume. So I would just calculate concentration by taking the number of moles and dividing it by the volume. So in this case, I just put 2 moles on the top and 0.5 liters on the bottom, and I should end up with 4 moles per liter. Now, I can always change this moles per liter, and instead of writing moles per liter, I will write just a capital M, and it's the same. So in the first one, I gave you a number of moles and the number of liters. In this problem, I'm giving you something else. In this problem, you're given 58.44 grams of sodium chloride, and it's dissolved in water in order to have a volume of 1 liter. What is my concentration? So again, we're looking for concentration. Okay, and in concentration, you need to know number of moles over liter. Now, we're not given moles in this problem, we're given grams, but what can we do in order to convert grams to moles? We're going to need our molar mass of sodium chloride, and in this case, it's 58.44 grams per mole. So if that's the case, let's go ahead and do a conversion. Now, 58.44 grams of sodium chloride, and you're going to multiply that by the molar mass. And when you calculate this, you should end up with 1.000 moles. Now that we know the number of moles, and we know the volume, we can go ahead and calculate concentration. So concentration is equal to 1.00 moles divided by 1 liter, and that should give you an answer of 1 mole per liter. And again, I can shorten that by 1 capital M because capital M is the same as moles per liter. Now, if I were really to make a 1 molar solution of sodium chloride, what I would do is I would add the sodium chloride into this volumetric flask. And I would go ahead and add, let's fill it up with a little bit of water, halfway through with water, and mix it until you get a dissolved solution. And once you have this dissolved solution, you can go ahead and fill to the mark. And when you fill to the mark of a volumetric flask, it is the exact volume. So when we make 1 liter, this is going to be exactly 1 liter. And that's how you would use this, calculating concentration, how much you need to use in a laboratory setting. Now, let's say instead of us knowing the number of moles, let's say we know the concentration and we also know the volume. We want to find out how much we need to make, or how many moles are in the solution. So we would instead, here in this problem, we're going to have a 0.500 molar solution of calcium fluoride, and it's asking us how many moles are present in 250 milliliters. So the first thing you look at this problem is that you know that concentration is always the number of moles divided by the volume. And so we are given the volume, but if you look at it, I have the volume in milliliters. And we don't usually have concentration in milliliters, so we have to do a conversion for this. So 250 milliliters, if we convert that, should become 0.25 liters. Now that we have this, we can go ahead and rearrange our equation, because we're looking for the number of moles. If we're looking for the number of moles, in order to get number of moles alone on this side of the equation, I have to multiply both sides by the volume. And so number of moles is equal to concentration times volume, which is equal to 0.50 and molars times 0.25 liters. Now again, I can go ahead and change my capital M for molarity to moles per liter because it's a derived unit. And if I go ahead and calculate this out, I can cancel out liters and end up with only moles as my unit. And you should end up with 0.125 moles. But if I really wanted to do this with correct sig figs, my answer should be 0.13 moles. So we encountered number of moles and volume given to us in a problem. You've also encountered the mass and the volume given in a problem. And you've been given the concentration and the volume. And you had to look for the number of moles. In this problem, though, I'm going to actually take it a step further and show you how it's used in a real-life scenario. So, for example, you're a student preparing for an experiment, and you need to make 100 milliliters of a 2 molar copper sulfate solution. What you need to do is weigh out the copper sulfate, and you don't know how much you have to weigh out. So, in order to do that, you have to do some calculations. And the first thing we're going to write is all the things that we know. So we know that concentration, again, like in all the other problems, concentration is equal to the number of moles per volume. And we need to know grams. Now, if we want to know grams, we're going to have to do a mole to gram conversion. So this is the extra step that we need to make. Again, like the last problem, number 3, we're going to solve for number of moles. So number of moles is equal to the concentration times the volume. And again, if you look at our volume, it's in milliliters, so we need to do a conversion. And that turns into 0.1 liters. So 2 capital M, so that's moles per liter, times 0.1 liter. And again, if we do the cancellations of the units, we should end up with number of moles, and our final answer should be 0.2 moles. Now that we know that, we can go do our conversions from moles to grams. So we need to find out the molar mass of copper 2 sulfate, and that's 159.61 grams per mole for copper 2 sulfate. And now that I know this, I can go ahead and do the conversion. 0.2 moles and times 0.2 moles times 159.61 grams should become 31.92 grams. And if we were to really do this in correct sig figs, I should have 30 grams of copper 2 sulfate. That's how much I need to weigh out. Now, that is the last of our slides. So again, molarity is the number of moles of solute per liter of solvent. Molarity is the same as concentration. And the equation that we need to know is that molarity or concentration is number of moles of solute per liter of solution. So molarity and concentration again are synonymous in chemistry. In your packet, you should have a few more examples. Go ahead and try do those example calculations, and if you have questions, you can ask me in class. Thank you.